Yes, you in Videoland, we've been talking about math. That's what we've been talking about, math. Not COVID and some of my ideas. Okay, guys, stand up, stand up. If you can turn your videos on, turn them on, because it's so much easier for me to teach when I see your beautiful faces. Stretch, stretch. Say Good Friday, Good Friday.
Good Friday.
Good Friday. Okay, let's sit back down, let's sit back down. I want to talk a little bit about nuts and bolts to start. We have a what next Wednesday? Quest, our first quest, okay? So part of it's going to be WebAssign, and that's why we've had two WebAssigns, because I don't want on next Wednesday, to be your first experience with WebAssign. So what will happen next Wednesday is I will probably teach for the first 20 minutes and give you the last 30 minutes to take the quest. I'll open up a WebAssign to open up at the end of class, at that last 30 minutes, but I'm also going to open up a Canvas assignment that'll be a PDF, that'll be a handwritten component of the test. So I'll need you guys to be able to scan, and this, Dr. Warren, this is a nightmare, scan your handwritten solutions and then give them to me as an assignment, turning in your scan as an assignment. So what I want to do now is I'm going to run over to the computer and show you a link I put up to show you how to scan. So I'm now coming to the front of the room, and I'm going to share my screen. Here's our Zoom. Can you guys see, can you guys see our canvas? Is that showing to you guys now?
Yeah.
Okay, so then I'm just going to go to announcements. Now this is where I put the lecture videos. So here's the lecture videos, and I'll keep doing that as the semester goes on. Here's the Zoom office hours, to make Zoom office hours. Here's our homework for chapter 2. That's kind of where we're at. Right now, we're hugging pretty tight into these, and after today, we should be able to free up a lot of 2.4. Okay, what sections are on the quest? Good question. 2.1, 2.2, 2.5, and a little bit of 2.4, and a little bit of 2.4. Those will be the sections. A lot of it will be like the homework. A lot of it will be like the homework. Now this is the announcement right here. If you have an Android phone, you would watch this video. If you have an Apple phone, you would watch this video. If you have an Android phone, you'll need your Google Drive app. So if you don't have a Google Drive app, you'll want to download that anyhow. But this guy...
My name is Cynthia, and welcome back to the channel where we make educational technology easy for students. Now it also gives you the option to add multiple pages in a single PDF file. And then finally,
so you can see even at an angle, he's just
going to tell Google Drive that we're happy with
it scans in.
So title, press save, and automatically uploads it.
So if you have an Android phone, I need you to watch this video, and then I want you to play around with it. I want you to try to scan some stuff. This will help you in all your classes. If we get stuck online, this will help you in all your classes. If you're an Apple user, you use your notes, and then you can just watch.
Hi, this is Gary with MacMost.com. Let me show you how you think, and it's going to make the adjustments. And I can keep scanning.
Look back. So does this make sense? Does this make sense? So sometime between now and Wednesday, play with that. Try scanning some things, writing on paper, and then seeing how it scans, so that by Wednesday, you're just ready to go with it. You're just ready to go with it. Okay? Are you with me? Okay, cool. I can see those heads. Let's go back to where we left off. Well, I guess we need to stand up again. You're like, Dr. Warren, you do need to stand up. I can see already you're sound asleep. Your eyes are open, but you're sound asleep. Mason's like, I'm not standing. There we are, Mason. Good. Stretch, Mason. Oh. Okay, tell somebody, wake up. Look at somebody and say, wake up, wake up, wake up.
Wake up!
Yeah, there we go. Thanks, Thomas. Okay, sit back down, sit back down. I'm hoping at this point, graphically, you can find the limit from the left and the right. That's what I'm believing. If I give you a graph and ask you to find the limit from the left and the limit from the right, how many people are getting more comfortable with that and feeling like they may... Now, one of the flashcards, the actual limit, if the left-hand limit does not equal the right-hand limit, what can we immediately say about the real limit? What can we immediately say about the real limit? Does not exist. Like if this goes to 7 and this goes to 5, the limit doesn't exist. The only way it's going to exist is if both of these are the same number. If this goes to 5 and this goes to 5, then the real limit's 5. But we don't like graphing. We hate graphing. We want to attack things algebraically, and that's where we're heading. We're looking at making limit tools, and we did 2 of them last time, you might not remember. Our first flashcard for really doing things is this one. Now read this to me. Read this to me.
The limit
as
approaches C.
As x approaches c of x is the number
Z.
c. Okay, and once again, I want to show you. Here's my function, f of x equals x. Here's my function, and this graph is exactly the one we had in the last class. We're just refreshing. Now, if I approach 7 from above, if I look at the limit as x approaches 7 from above, I start here, and graphically I do what? Graphically I do what? What do you do from that point? Great, you come up, you go over. Now this, if I come up over here, that number is 7. That number is 7. Because when you plug 7 in to your function, you get 7 out. And we can see that the limit as x approaches 7 from the right is 7. By doing what we were doing graphically. Now what if you come from the left? I mean, you guys just think, well, look at it. What do you think is going to happen as you come in from the left? If you're coming in from that side, what does it look like it's going to graphically? 7. It also goes to 7. Are these 2 numbers the same? Are these 2 numbers the same? So then the actual limit as x approaches 7 of x is 7 also. And guys, it doesn't matter that it's 7. If this was a 10, it would still be the same thing. It would go to 10. And so this is what this is saying. No matter what the c is, the limit as x approaches any number is just that number. Is just that number. And that was our first real big limit tool. The second one is, what if it's a constant function? What if it's a constant function? And I call this a dead man's function. Say that.
Dead man's function.
A dead man's function. Because ultimately, all of our EKGs will look like this. You're like, Dr. Warren, you're sick. You're sick. No, I'm real. Carpe diem. Say that.
Carpe diem.
Seize the day. Seize the day. We don't want to be a constant function now. Does this make sense? Okay. So what happens is, whenever I see a constant function, I always think of my mother. My mother would come into my bedroom and she'd be like, clean your room. Because it always looked like a pigsty. Clean your room. I'm like, Mom, I'll do it later. And she's like, now. And I'm like, no, Mom, I'm going to clean my room. And then she's like, I'm not going to do it now. I'm going to do it later. And she goes, you're going to do it now, young man. And I'm like, I'm not doing it now. And I'm like, well, what if I do it tomorrow? Now. No matter what I said, her answer was not changing. And that's the way a constant function is. I don't care if you're 15, it's like my mom. F of 15 is going to be 5. If it's 7, F of 7 isn't going to change. It's going to be 5. No matter what you pick, you're always going to get 5. So if I've got this C here, F of C is going to be 5. Now let's look at the limit as x approaches c from the right. Dr. Warren, was a focus. Let's look at the limit as x gets closer and closer and closer to c from the right. the range values are always, no, irregardless, the range values are always, like my mom, the range value is always 5. You come in from the left. It's like my mom. It's always 5. It's not changing its mind. It's constant. Does the limit exist? Graphically, does the limit exist?
Yes.
Yes, and what number is it?
5.
5. Okay, so this is what limit tool 8 says. Whenever you have a constant, whenever you have a dead man's graph, the limit as x approaches c is just going to be that constant. The limit as x approaches c is just going to be that constant. Now I'm going to see if this registered in your brain. I'm going to give you 2 limits, and you see if you can figure out what these are. So here's question number 1. What's the limit as x approaches 21 of x? And then what's the limit as x approaches 21 of 7? See if you can answer those. Try to answer those now at your seats. What is the limit as x approaches 21 of x? And what's the limit as x approaches 21 of 7? Okay, now I'm running to the front of the room. Hold up what you got for me. And let me see your answers. What do you got for me, guys? What do you got? What do you guys have for me? Some of you aren't holding up. Oh yeah, Zach, that was awesome, Zach. What do you got for me, Henry? You got anything for me there? Yeah, Henry. Kelly, what do you got? Oh, you're like that one I'm across the room. Thomas, what do you got for me? Thomas, what happened to that eye? Thomas, what do you got for me?
So writing it down.
Okay. Lindsay, you got anything? Okay, I'm going to the back of the front of the room. I'm going to come skipping into the picture this time. Da-da-da-da-da-da-da-da-da. Why are you doing that, Dr. Warren? To wake you up. So here, what is the limit as x approaches 21 of x? What is it? 21. You're using this flashcard. No matter what, the limit as x approaches c of x is just c. Now, how about the limit as x approaches 21 of 7? What's the answer of that? Zach was right. What's the answer of that? It's 7. It doesn't change. Does this make sense? You're going to be able to need to do this like hitting a ground stroke. That should be an easy ground stroke for you. Okay. Now what I want you to do is I want you to go into our Canvas, and open that Limit Tools PDF. Go into our Canvas and open that Limit Tools PDF. Okay, and I'm going to try to share that with you. Okay, so can you guys see this? Can you guys see this at all?
Yes.
Okay. So what you see here is right now, we've got this limit tool here. The limit as x approaches c of x is, focus, the limit as x approaches c of x is, put your hand on that space bar. We're going to try to break the speakers in this room. We're going to try to, okay, all together. The limit as x approaches c of x is
C.
Okay, we're going to break them. You can yell louder than that. Number 8, the limit as x approaches c of k is k. Okay, so now we're going to come back up to these 4 limits. The limit of a constant times a function, say that.
The limit of the constant times the function
Is the constant times the limit of the function.
is the constant times the limit of the function.
Okay, The main difference between Math 205 and Math 235 is we prove a bunch of these in 235. We just don't have time. I only have you 3 times a week. I'm so jealous of high school teachers. Now I'm back to the front of the room. Okay, so for that first limit tool, anytime you run into something like this, anytime you run into something like that, you've got the limit as x approaches 5 of 7 times f of x. That first limit tool, and this is by limit tool number 1, this is what we're using. By limit tool number 1, you can take this 7 and pull it out. You can take this 7 and move it in front of the f of x. That's what limit tool number 1's saying. So like for example, if I saw something like this, and again, I can't really see how fuzzy I am to you guys, and I imagine for some of you I'm pretty fuzzy, but for others I might be clear. Can you read this to me? Can you read this to me so I know you actually can see it?
The limit as x approaches to
Of 8x. So if I want to figure out what this is, I can do what with this 8? I can do what with this 8 by using limit tool 1? What can you do with this 8? Get it out of the limit. And now we're there. But this is by limit tool 1. This is by limit tool 1. What limit tool would allow us to do this limit? What limit tool? Look at those limit tools. Which limit tool would allow you to evaluate this limit? Anyone? Anyone? Anyone?
7.
7. By limit tool 7, and this is my justification, by limit tool 7. Now I'm not going to make you justify every single step in every single problem. But I might make you do it in a couple. Because I don't want you to be thinking it's magic. I don't want you to be believing it's magic. Math is magic, Dr. One. Math is hard. I hate math. I mean, math is so beautiful. I know you don't want to hear it. Math is so incredibly freaking cool. I mean, it's everywhere. You pull this thing out of you pull this thing out. All the stuff it does is math. I mean, everything, every little picture you pull and take your fingers in, woo, it gets real big. Math. It's everywhere. I know I'm only excited about math. Okay. This goes to the number 2 by limit tool 7. The limit as x approaches c of x is c. Okay, now everybody should be able to answer what's 8 times 2? What's 8 times 2? What's 8 times 2? 16. So this is an example. No matter what the function is, if you have a constant times it, 7, you can pull that constant outside of that limit. That's that limit tool. Now go back to your limit tools. I'm running back up here again. I'm going to have a heart attack. Not kidding. I jog. Okay, now let's look at limit tool number 2. Read limit tool number 2 to me.
limit as x approaches
To c of
f of x plus or minus g of x
Equals the limit
as the limit of x approaches c f of x plus or minus the limit as x approaches c g of x.
Perfect. Now I'm running back up here. Now I'm here again. So if you're looking at something like this, the limit as x approaches 3 of x plus 5. Now you got the line x plus 5. We're not going to graph it though. By limit tool number 2, this is the same thing as the limit as x approaches 3 of x plus the limit as x approaches 3 of 5. What limit tool have I used to go from here to here? What limit tool have I used to go from there to there? If you were giving a justification, what limit tool have you used? Anyone?
Where did the 5 come from?
Oh, what was this number? What did I call that number?
That's a 5? I thought that was a 3.
Sorry, it probably was, now it's a 5. This is the way it is living with me, okay, too. It was, things change. The limit as x approaches 3 of x plus 5 is equal to the limit as x approaches 3 of x plus the limit as x approaches 3 of 5. If I had to give a justification, and it's just the limit tools on the sheet, you won't need any more limit tools than what's there. Out of all of them, which one does it look like I've used so far?
Number 2.
Limit tool number 2. So this would be by limit tool number 2. Now help me out. I'm going to make a move and you're going to provide the justification. This limit is 3. What can you use that would allow that to be true? What limit tool would allow that to be true?
7.
By limit tool 7. And this is equal to 5. What limit tool did I use to justify that? What limit tool would I use to justify that?
8.
By limit tool 8. And what is 3 plus 5? This is just arithmetic. What is 3 plus 5? Everybody should put your hand on your space bar. Put the hand on the space bar.
8.
8. I want to hear it again.
8.
8. We could rap.
8.
8. I can't rap. I could try to rap. That's the last thing you'd ever want to see. And I'm videoing it, so the last thing I want to see is me rap. Okay, so we have this. Are you following? Are you with me so far?
Yes.
Okay.
Yeah.
Look at limit tool number 6. Look at limit tool number 6. What picture is beside limit tool number 6? An explosion. This is my do not exist limit tool. Whenever you're looking at a limit of a fraction, English is coming. I know if I keep talking like this, you won't listen. So now I have to change my voice. All right, boys and girls, we are here now to learn about taking the limit of a function over a function. Okay. Now, anytime you plug the C in, okay, and you get an f of c that's not 0, give me a number that's not 0. 2, like if this was a 2, and you plug the c in, and the denominator is 0. Dr. Warren, you gotta stop. The denominator is 0, then you can immediately say the limit. Does not exist. That's our nuclear explosion tool. Okay? If the limit existed, every number would be 0. If the limit did exist, every number would be 0. And we can prove that. So when the numerator's not 0 and the denominator is 0, what can you immediately say about the limit? Just volley, slam it right down, right at the net. Does not exist. Let me give you an example. Like for example, can you guys see this part of the board? Can you see that part of the board?
Yeah.
So like for example, suppose I was looking at the limit as x approaches 2 of x plus 5 over x minus 2. When you plug a 2 into the numerator, what number do you get? 7. But when you plug it into the denominator, what do you get? 0. By my limit tool number 6, thank you. You knew I was floundering there, dying, okay. By limit tool number 6, we can immediately say, what about this limit? Does not exist. These should be the easiest questions on the quest. This should be the easiest. If you have to do that limit, You should be able to immediately say, oh look, this is going to 7, this is going to 0, does not exist. Limit tool number 6. Does this make sense? Does this make sense? Okay.
I have a question. Does that
Yes.
work for either side? So like if L was going to be 0, but M could not equal 0, would that still be does not exist?
Paris, is that you?
Yes.
Paris, did I pay you to say that question?
No.
Okay. This is the thing.
Will you pay me to say that question though?
Yeah, I will give you something better than money. I will give you knowledge. Sorry, no, how lame does that sound? Like my dad would say stuff like that. I'm not going to give you an allowance. I'm going to give you knowledge. And I'm like, oh, thanks. That's what I wanted, knowledge. I just want to watch TV. Okay. The derivative. Calculus is about limits, derivatives, and integrals. What is calculus about? What's this class going to be about?
Limits, derivatives, and integrals.
Okay, we're going to say it again. What's calculus about?
Limits,
Put your hand on your spacebar. Put your hand on your spacebar. What's calculus about?
limits, derivatives, and integrals.
And integrals of functions. This is the definition of the derivative. You're not ready for this. You can't handle the truth right now. You can't handle the truth. But I'm going to write it down anyhow because Paris really asked a wonderful question. Well, Dr. Warren, what if this goes to 0 and this goes to 0? Could the limit exist? And the answer is yes. And in fact, the derivative of a function, like at 2, is defined to be the limit as x approaches 2 of f of x minus f of 2. This will not be on the quest. This will not be on this quest. Divided by x minus 2. This is the definition of the mountain we're going to camp around most of the semester. We're not going to do a lot of integration. We're going to invest a couple weeks in limits. We're living with derivatives. But notice here, Paris, if you're looking, when you plug a 2 in for x, what happens to the denominator? What happens to the denominator? 0. If the numerator didn't go to 0, we could use our nuclear explosion to say it does not exist. But when you plug a 2 in for x, you get f of 2 minus f of 2, which is 0. And most of the time, these limits do exist. Most of the time, these limits do exist. Excellent question. Okay, stand up again. I know you already need it. Come on, stand up. You're like me. You're ADD. I know you're ADD. Okay, I'm running to the front of the room. I'm going to die. Okay, read limit tool number 3 to me.
The limit of x
approaches
C of
x
times
c of x equals the limit of x approaches c of f of x times the limit of x approaches c of g of x.
you guys are so awesome. I wish I could see all your faces. You guys are so awesome. You play so well. Okay? Yeah. So if you have the limit of two functions timesing each other, I have to use the proper word. The limit of a product, say that,
the limit
is the product of the limits, say that.
is
The product of the limit.
Okay. Like, for example, let me show you a perfect case where we use this. Imagine that I've got x squared, and I want to take the limit of this. Well, what does x squared mean? Explain to your little brother or sister. When you're explaining, what does that little number mean? What would you tell them? X times x. This is, the limit as x approaches 3 of x times x. But this is equal to the limit as x approaches 3 of x times the limit as x approaches 3 of x. Here's where I've used limit tool 3. This is where I've used limit tool 3. Now you're going to say this with me. Get your hand on that space bar. You're going to say this with me. The limit of the product
The limit of the product
is the product of the limits. So if you have the limit of f times g, it's equal to the limit of f times the limit of g. It's equal to the limit of f times the... No, I'm not going to make you guys do this much, but I want you, what limit tool would allow me the next move? What limit tool would allow, focus, what limit tool would allow me the next move? This is the same thing as 3 times 3. If you had to provide a justification on the quest, what limit tool, write down, what limit tool did I use? What limit tool did I use to go from this step to this step? Write it down, write it down, write it down. What limit tool? What limit tool? Write down what you're... It's one thing to copy what I have. It's another thing to actually use your brain to try to figure it out. This is called active learning. Okay, now, put your hand on the space bar. Put your hand on the space bar. Yell out whatever number you had. Yell out number whatever you had.
7.
It is 7. It is 7. It is 7. Okay, look at limit tool number 9. What's beside limit tool number 9?
A sword.
A sword. I call this limit tool slasher. Say it, slasher.
Slasher.
This ends up being our favorite limit tool. This ends up being our favorite limit tool. Slasher. Anytime two functions are equal everywhere but one value, their limits are the same. Their limits are the same. Let me give you an example. If I look at this function, read it to me. If I look at this function, read it to me. What is this function? What is this? Can you read that?
X squared minus
4 over x plus 2. And then I'm going to look at this function g of x, which is equal to x minus 2. I want to look at the function g of x, which is x minus 2. Which function looks more complicated? Which would you not want to meet in a dark alley, f or g? Which would you not want to meet in a dark alley, f or g? How many people think they could take the limit of this guy? How many people are pretty confident they could take the limit of that guy? With some of the stuff that we've done today. Now this guy we're not so sure of, but let's use some algebra. This is the same thing as x plus 2. Factoring. We spent a whole day factoring. Times x minus 2. Well, one person was in the classroom. I taught one person that day. Okay? But the rest of you watched the video. Now, one of the things you're going to have to do on Wednesday is talk about domains. What's the domain of this function? What's the domain of this? Is there any division? Is there any division?
No.
Please say no. Is there any square roots?
No.
So it's all real numbers. It's everybody. Everybody. Is there any Gary Dreibel-Bisses in this guy? Is there any Gary Dreibel-Bisses? Is there any evil in this one? Who's not allowed to play? Who's not allowed to play?
Negative 2.
Yeah, x is not allowed to be negative 2. If I use some algebra, this is the same as x minus 2. And you can be fooled into thinking, oh look, Dr. Warren, f is the same as g. No. It's the same as g everywhere, but who got kicked out of this function? Who got kicked out of this function? Negative 2 is perfectly okay here. They look the same algebraically, but they're not the same function. Limit tool number 9 says, the limit as x approaches that bad guy, negative 2, of this function goes to the same thing as the limit as x approaches negative 2. Oops. That's a minus of that function. In your justification, you can even just say by. You can just say by what? By what? By what? By what? By what? By what? Slasher. Or you want to be more elegant, limit tool number 9. You want to be more elegant, limit tool number 9. Okay, imagine I still wanted to find out what the limit was. I just got to ask, can you distribute the limit? Can you distribute the limit of, is the limit of a sum the sum of the limits? Dr. Warren, I'm not focused, get in my face. Is the limit of a sum of the limits? Is the limit of the sum the sum of the limits?
Yes?
What limit tool? Stop, Dr. Warren. What limit tool?
2.
Limit tool number 2. Yeah. Who was that? Joaquin, thanks, man. Okay, so could I distribute the limit across? And Joaquin says, you sure can, Dr. Warren. This would be the same thing as the limit as x approaches negative 2 of x minus the limit as x approaches negative 2 of 2. And if your justification, it would be by limit tool 2. That's exactly what I wanted. Now, you guys are going to help me out. You have it. If I pass the ball to you at this point, you should be able to shoot immediately. Okay? I throw the ball, you are LeBron. You are LeBron. You know the shot. What limit tool would allow me to do that limit? What limit tool would allow me to do the first limit? What limit tool? LeBron, make the basket. You're LeBron. You're LeBron. 7. What limit tool would allow me to do that one? What limit tool would allow me to do that one? Little harder shot, LeBron.
8.
Limit tool number 8. Limit tool number 8. Golden. So tell me, what would this limit go to? What would this first one go to? What would this first one go to, LeBron?
You're blocking it, Dr. Warren.
Oh, sorry. What would this go to? What would this limit go to? What would that first limit go to?
2.
Negative 2 minus, what would this limit go to? Too many damn 2's, Dr. Warren.
2.
It goes to positive 2. Now this is where your math skills start hurting you. What is negative 2 minus 2? Negative 4. Negative 4. It's never the calculus. It's never the calculus. It's always the algebra. It's always the algebra. Okay, stand up again. Stand up again. You've got 10 more minutes of misery on Friday with Dr. Warren. Now again, the way I get my attendance is by, Zoom just captures you all for me, so it's super easy. Okay, as I'm thinking about Monday, I want you guys reading section 2.4. So if you're thinking about homework, I want you guys reading section 2.4. And I want you starting the homework, that's in 2.4. Now, you don't quite have enough information to like knock it all out, but you can start it. So read section 2.4 and do that homework in section 2.4. There will not be another web assign before the quest.
Dr. What day is the quest again?
Wednesday. Thank you. Guys, I guess I gotta ask this again. Is this better than video? I mean, would you rather just have me have a video, or is this better than the video?
I like the
Much
plan.
better.
So it's okay. I mean, I just worry that it's blurry and you're not getting what you need out of it. But it's better than just looking at the video of me.
More interactive.
Okay, that's kind of this is the way I teach. It's always ground shots. I volley, you volley. You're wrong, I'm wrong. Where you're right, I'm right. I mean, this is the way it is. Okay. Now, I'm going to go back to the front of the room and we're going to look at some kind of homework questions. Well, I guess maybe there's one other one. What's limit tool 4? Look at limit tool 4. What's limit tool 4? Now, I'll read it to you. I have it memorized. Limit tool 4. The limit as x approaches c of f of x over g of x. Am I right so far? Am I right so far?
Yes.
Is equal to the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. Is that what it is? Is that what it is?
Yeah.
Okay, now you guys are going to say this. The limit of a quotient is the quotient of the limits.
The limit of the quotient is the quotient of the limit.
The limit of a product is the
Product of the limit.
the limit of a sum is the
Sum of the limit.
yeah, so you can take them across everything. You can take them across everything. Unless the denominator goes to 0. Unless the denominator goes to 0. Okay, now I'm running up to the front. I'm going to share a screen. Oh. Okay, now. Okay, do you guys see these questions?
Yes.
Okay. So, what I want you to look here is, they're not telling me the function. They're telling me that the limit as x approaches a of f of x is the number what? Is the number what? Now I'll actually see if you're right. 3. And the limit as x approaches a of g of x is also the number 3. Okay, look at number 41. What limit tool would help you do number 41? Two. The limit of a sum is it's all in the words, the limit of a sum is the sum of the limits. Okay, so what would the limit as x approaches a of f of x equal? And I'm helping you by pointing to the answer. 3. And what would the limit as x approaches a of g of x equal?
3.
What is 3 minus 3? 0. What? No, they're wrong. No, they're wrong. They're wrong. It's 0. It's 0. I got the wrong answer. Nice. Okay, let's try the next one. Okay, can I distribute a limit across a minus? Can I distribute a limit across a minus? And the answer is yes. In fact, you guys remember the question. I will lose it on my way up to the board. Okay, I had the limit as x approaches a of what? Of what? Help me out. I've already forgot. What is it? You're gonna ghost me?
F of x minus 2 f or g of x or something.
G of x. Okay. I'm gonna make a move and you guys are gonna provide the limit tool. This is equal to the limit as x approaches a of 3 times f of x minus the limit as x approaches a of 2 times g of x. By what? What limit tool have I used? What limit tool have I used? You're like, Dr. Wynn, that looks like complete gibberish. The limit as x approaches a of 3 times f of x minus the limit as x approaches a of 2 times g of x. What limit tool have I used?
2.
By limit tool 2. Next limit tool. This is the same thing as 3 times the limit as x approaches a of f of x minus 2 times the limit as x approaches a of g of x. A little harder. Look at those 12 limit tools. Look at those 12 limit tools. Which one would allow me to pull that constant out of the limit? Out of all those limit tools, which limit tool out of the 12 would be the one that would allow me to do that?
1.
By limit tool 1. Now, that stupid book, if it's, I'm running back up, sharing the screen. Okay. So we're here. Now, let's just make sure we got it right. They're telling me the limit as x approaches a of f of x is 3. The limit as x approaches a of g of x is 3. So this would be 2, Oh, I guess we've got it a little bit different. I guess ours is 3
Sorry.
and 2. No problem, it's all good. We'll just change our, it doesn't matter. They're both 3, so this would be 6 minus 9. What is 6 minus 9? What is 6 minus 9?
Negative 3.
They got the wrong answers with the book. Unbelievable.
I feel like I've noticed that for a few other ones too.
Nice. Okay. Let's stop this nightmare. I'll have to let them know. Okay, we're just gonna finish with a ball buster, okay? We're just gonna go all in. This is going to be a tough looking question, and you're gonna see if you can help me answer it. I am not going to justify every single step, I don't have time. I'm gonna look at this beast.
Dr. Warren, is X approaching 1?
Yeah, x is approaching 1, so I think.
Okay. And then that's a 3, right? 3x?
Yes, I'll read it here. This is what I'm looking for. I'm looking at the limit as x approaches 1 of x squared plus 3x minus 4 divided by x squared minus 1. And you're like,
Thank you.
Dr. Warren, I hate math. Dr. Warren, I hate math. No, just don't panic. Let's see if the do not exist tool works. When I put a 1 in here, I get 1 minus 1, which is 0. If the numerator goes to any other number other than 0, the problem's done. Do not exist. Game over. But when I plug it in here, I'm going to get a 1 plus a 3 minus a 4. And you're like, ooh, 0 over 0. It may exist, it may not exist. Now, what's your best algebra friend in calculus?
Factoring?
Factoring. Can you factor that? Try that. Can you factor that? Some of you are smiling. How many people own the denominator? How many people own the denominator? How many people are like, Dr. When I got the denominator for you, I can do that. I can throw that at you. What is x squared minus 1? What does that factor into?
X
Plus 1 plus x minus 1.
Now, I'm going to give you guys a hint. I shouldn't give it to you. It's cheating, really. Because it's a 0 over 0, you know the 1's making it 0. So this is cheating, but you will know one of the factors has to be x minus 1, because you're going to have to get rid of it. Whatever this is, if it's causing 0 over 0, one of the factors is going to be x minus 1, which is a huge help in factoring this. Well, you need an x squared, so this has got to be x. You need a 3, but you also need the 4. What does this have to be?
Plus 4.
Plus 4. And so this is just by algebra. This is just by algebra of the reals if I'm making a justification. Now, go grab slasher. Go grab slasher. And you go slash, slash.
Professor Horn, the two factors in the numerator, wouldn't that, oh, I'm sorry, I read the problem wrong, never mind.
No problem whatsoever. So this would be by limit tool 9. No, I don't have time to lay out the rest of it, but I just got to ask, is the limit of a quotient of limits? Is the limit of a quotient of limits?
Yeah.
Could I take the limit upstairs and take the limit downstairs? Could I take the limit up here and the limit down there? Yes or no? The answer is
Yeah.
yes. I could distribute the limit across the pluses, and then I could use limit tool number 7 and use limit tool number 8. But essentially at this point in time, since there's no more division by 0, you can just plug in the 1. You can just plug in the 1. And since I'm not making you prove it, the answer would just be 5 over 2. The moment you get rid of the division by 0, at that point in time, because of continuity, which is what we're going to talk about next time, you can just plug it in. You guys are great. You guys are great. Thanks for coming out and playing with me. Thanks for coming out and playing with me. Have a safe weekend. Have a safe weekend. Stay well. That's the most important thing. Stay well, okay?
Thanks, Doc.
Thank you.
Thanks, guys.
Have a good weekend.
You're great. Stop that video.